Hello and welcome to another walkthrough. Now this time it will be Edexcel A2 level further maths called Pure Paper 2 May 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough, I might be making mistakes, which I'll correct if I realize in the walkthrough. But if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. And I'm going to start the timer now. Okay, let's go with this paper. Number one, what do we have here? Complex number. Given that z equals that, w equals that, show that z over w equals absolute. All right, just, absolute modulus here. Okay, so z equals w would be 2 minus 2 root 3i divided by minus 1 plus root 3i. Yeah? And then we want to find the modulus of that fraction. So I'm going to do left hand side first and prove that it's equal to the right hand side separately. So left hand side, we should just make the denominator not a complex number first. By that I mean just multiplying by a conjugate. So just multiplying by the conjugate of the denominator. So that would be minus 1 minus root 3i over minus 1 minus root 3i there. And then you find the modulus of all that. That's the left hand side. Well, the denominator would just be 1 plus 3, which is 4. And the numerator, so basically just expand them all out. So I get minus 2 here for the real part. And minus 2 root 3 times minus root 3, just the numbers. I get 3 times 2, which is 6. And then I times I get minus 1, so that's minus 6. So minus 2, minus 6 here for the real part. I hope you follow that. And then I have minus 2 root 3 times minus 1, so that's 2 root 3. And then with the minus 2 root 3. Well, that's good because they cancel, right? So that's it. That would be that. Let me double check that if they actually cancel. So 2 root 3i and then minus, okay. So this is 2 basically because the modulus of minus 2 would be 2, right? And then the other one would be the modulus of z, which is 2 minus 2 root 3i divided by the modulus of w, which is minus 1 plus root 3i. Well, we need to do separate now, so I'm just going to do a Pythagoras. That would be 4 plus 2 root 3 squared would be 12, right? So that's 12 divided by square root of 1. That's not 1. 1 plus, what's that again? Root 3. Okay, 3. So that would be square root of 16, which is 4, over square root of 4, which is 2. So that's 2. So left hand side equals right hand side as required. So I proved that. Part B. The argument of zw equals the argument of z plus argument of w. Okay, so argument of that zw, we need to find zw first, right? So zw would be that, right? Just write them out first there. Okay, like this. And then we're going to expand, so we get a minus 2 here and a what here for the real part. So that's again minus 2 root 3 times root 3, so that would be minus 6. Minus 6 times the I squared, which is minus 1, so I get 6. So minus 2 plus 6, I get 4, for the real part. And the imaginary part, let's see if they cancel. So 2 root 3i here times 2 root 3i. So that's plus 4 root 3 because we have 2 of the 2 root 3's. Is that right? Yep. Okay. So that's zw. And the argument of zw here is then equal to, well, this is in the first quadrant, so that's basically just arctan straight. 4 root 3 divided by 4, so that would be well, I happen to know that arctan root 3 is pi over 3. So we're going to keep that first. And the argument of z alone would be, well, that's 2 plus 2 and minus. So plus x minus y there for the z, that would be the fourth quadrant. Yeah. So the fourth quadrant, we just do negative arctan, yeah, because you have to sweep down. Negative, well, assuming that this is, yeah, this is from minus pi to pi, right? Yeah, assuming this is from minus pi to pi, so I'm just going to do negative arctan 2 root 3 divided by 2. That would be negative pi over 3, yeah? And then argument of w would be, well, that's negative x and positive y. That's quadrant 2. So it would be pi minus, yeah, arctan, I mean, if you imagine the quadrant there, root 3. Okay? And then that would be pi minus, well, arctan root 3 is again pi over 3. So pi minus pi over 3 will be 2 pi over 3. Okay? So if we add them up, argument of z plus argument of w is going to be equal to pi over 3, right? Because that adds that. We get pi over 3. That means, therefore, we have proven that the argument of z times w is equal to the argument of z plus argument of w as required. Yeah, so that one, basically this one is equal to this one plus this one, right? We have proven that. All right, so that's just proof work, algebra work, no problem. This one, number 2. An archer shoots an arrow towards a target. In the model, an arrow is a particle, flight path of the arrow is straight line, the target is part of the plane. Okay, relative to a fixed origin, the arrow is fired from the point with position vector. Okay, so arrow is here, yeah, and then there is a plane. Okay, plane. Okay, plane, normally they use this gamma notation here. And an arrow is fired from this vector here, 3 minus 5, 2. The plane containing the target has equation. So this plane is 2x plus 4y minus z equals 3. Yeah. Use the model in answer part A to D. Determine the shortest distance that the arrow must travel to reach the plane. So we can use the formula here. Let me show you the formula sheet. There you go. So the formula sheet is the distance, perpendicular distance between a plane and a point. So it's the last one here, yeah? The last one here. Okay? So that's basically D equals for part A. Part A, yeah? D equals. So basically the n vector here, which is the normal vector of the plane, well, because they have the Cartesian form, so the n vector, I'm just going to write like this, is 2, 4, and minus 1. Yeah? And then we have to move everything on the same side, so that's going to be plus 4y minus z minus 3. So that would be the value of D, yeah? Just going to keep 1. I mean, D as in the one in the formula here, not the shortest distance. Okay, let me change this to capital D. Okay. Yeah, and then we're going to have absolute, okay, so n1 is 2. That's the first component of the normal vector, times the first component of the point, which is it was 3 minus 5, 2, right? Yeah, okay, so 2 plus, and then the second normal component is 4. The second is minus 5. Basically similar to a dot product between the normal and the point, and then you must add the minus the plus d too, right? And then here is minus 1 times 2, and then the minus d here is a plus minus 3, all divided by the Pythagoras of the normal vector, 2 squared plus 4 squared plus minus 1 squared, like that. Okay, so I'm just gonna go back to the paper. There you go. And then we're gonna calculate that. So that's basically modulus of 6 minus 20 plus 6 divided by the Pythagoras of 4 plus 16, 20, 21 here. That should be 12 minus 20, so that's minus 8, so that's 8. 8 divided by root 21. Okay. I don't like the number here. Let me just double check everything. Did I plug in correctly here? 2, 4, minus 1, and 3. Okay. 2, 4, minus 1, and 3, and minus 3. And then the point is 3 minus 5, 2. 6 minus 20. Okay. I was fooled by my handwriting there. Okay, there you go. This is not 6. I thought minus 3 is multiplying minus 1, minus 2. So that should be minus 2 instead. Minus 2 and minus 3. I mean, the number looks weird. Like, I don't know. It just feels like I should check. And I normally do check anyway. So that's 6 minus 20. That's minus 12. Minus 14. Minus 2 is minus 16. And minus 19. That's weird anyway. Let me check that again. Yeah, that should all be fine, right? Shortest distance that the arrow must travel to reach the plane, which is the perpendicular distance. Minus 14, minus 16, minus 19. So it's 19 over root 21. Well, let's use a calculator to maybe just give it a decimal as well. So square root 19 over root 21. So that's about 4.15. What's that, meters? Is everything in meter here? Nope, just unit. Okay, that's fine. Okay, part B. Let's get on. Move on. The arrow hits the target at point with position vector. Okay. So this position vector must be on the plane, basically. Determine a vector equation of the flight path of the arrow. Vector equation. So we are assuming that it's a straight line. Yeah, okay. Otherwise, that wouldn't make sense. The flight path of the arrow is a straight line. Okay. So basically, we're just going to take this thing again. Okay, just to visualize. Okay. Give me 1 second here. Just switch off the fan. We have a point on the plane being, they already told you that, which is 6, minus 2, and 1. Because we're going to hit that target directly, like that point on the plane directly. So that's going to be something called a linear path here, or a straight line. So we should find the vector equation of the line first. Let's say this is line L. Right? And, oh yeah, it asks you to do that, so that's fine. So we're just going to use R equals A plus lambda B. So A can be just a point on this path. So we're going to take 3 minus 5, 2. That's easy. And then lambda is just some unknown constant. And B, sorry, is just the relative vector between these two. So we're just going to do maybe 6 minus 3 minus 2 minus 5, right? 6 minus 3 minus 2 minus 5, and 1 minus 2. So that would just be 3 minus 5 and 2 plus lambda times. So simplifying that, we get 3 minus 1. Yep, okay. That's the vector equation of the path. That's it. Part C. Determine the acute angle that the flight path of the arrow makes with the target. Okay, so it's basically asking the angle between this line and the plane. Well, the simplest way is to find the angle between the line and the normal vector. And we take the acute angle because, look, like it or not, if you find, so let's say this is the normal vector, right? If you find the angle between the normal vector of the plane and that line we want there, although it's not exactly the angle looking from this, but they want the acute angle in anyway, so somehow if you flip the plane around or looking from another angle, this angle theta will be the acute angle. Yeah, anyway. So bottom line is we can already find the angle between the b vector here, which is the direction vector of the plane, the line, and the normal vector of the plane. So we're just going to do theta equals arc cos the normal vector times the vector b divided by absolute n absolute b, basically just that. Okay, so this is a dot product. So what is n? N was so basically just 2, 4, and minus 1. That's the normal vector of the plane, and the direction vector is just 3, 3, minus 1 from the previous part. And then I think we already got the modulus, the length of the normal vector here, which was 4 plus 16, 20, 21. Yep. And that's 9 plus 9, 18, root 19. Weird number. Okay. So the top part is just what? Well, 6 plus 12 is 18. 18. Yeah. 6 plus 12, 18. 18 plus 1, so 19. Aha! That's why they have root 19 there. So this is just arc cos square root of 19 over 21, basically. Okay. So we want in degrees, right? Nearest degree. Okay. So change that to the degree first. Then arc cos fraction root 19 over root 21. So that is 17.975 blah blah blah, and that's nearest degree like that. 18 degrees. Acute because it's less than 90. Okay, that's part C done. Part D. Determine the distance traveled by the arrow. Okay, so that shouldn't be hard. Just find the distance traveled by the arrow. Although that's not going to be the shortest distance, right? But yeah, we can find the relative vector between these, and that is already the vector we found here. This vector, this relative vector between the arrow and the target is already this. So we just find the magnitude of this will give us the distance traveled by the arrow, right? So basically just square root of 3 squared plus 3 squared plus minus 1 squared. And that is just root 19, yeah? Distance traveled. So I can give it a decimal there. 4.36 units maybe. Okay. And then part E. Yeah. Comment on whether the actual distance traveled by the arrow is likely to match the answer to part D. Of course not. No. As the actual path is probably the first question I asked, right? Before I look at the question, like actually the arrow should travel in a projectile path. The actual path is projectile. Yeah? Or a curved, not a straight line. Yeah? And that's it. No, yeah, I already answered that. All right, next question. That wasn't too bad. Number 3. Given matrix A here, prove by induction that. Okay, so basically just prove by induction. So we're gonna prove by, the first step is to do the introductory step. Plug n equals 1. So a to the 1 equals, it's just 1, 0, 5, and then 2 to the 1 minus 1, just plugging into the a to the n there. Yeah, and this is 1, 0, so 2 minus 1 is 1, so that's 5, that's 2, equals a. Yeah, a which is given at first, so true for n equals 1. That's the first step. Yeah, the second step is called the hypothesis step, the assume step. Yeah, so assume n equals k. So we're gonna get a to the k would be 1, 0, 5, 2 to the k minus 1, and 2 to the k here. Okay? Assume, I gotta write assume true for n equals k, not, yeah, for n equals k. Yeah? Like that. So we're gonna keep this result and use in the third step, which is the inductive step, yeah, n equals k plus 1. So we would have a to the k plus 1 would be equal to, just substitute to the definition of the thing we're proving here first. So 1, 0, and then 5, 2 to the k plus 1, yeah, minus 1, and then down here I have 2 to the k plus 1. Right. Now, this is the definition of the thing we're proving, but a to the k plus 1 itself is a to the k times a, right? Algebraically speaking. So you are basically multiplying a to the k by the matrix A. So a to the k, we had it earlier. Yeah, we're going to use the assume step there, the result from the step 2, and multiply that with the matrix A, which was given to be 1, 5, 0, 2. So that's not too bad, right? And we just multiply out. So matrix multiplication here, so 1 times 1 is 1, and that times 0 is 1. I mean, it's 0, so we add up to 1. And then I do this element here, so that would be 5 plus 2 times 5 is 10, and then 2 to the k minus 1, just the whole brackets there. Yeah? Okay, yeah. And then 0 times 1 is 0. 2 times that is 0, so this is going to be 0. 0 times 5 is 0. 2 times that is 2 to the k times 2. You see, if we simplify that, right, we expect, I mean, because we are asked to prove that it works, so we expect this to be the same as that, right? Just get some Q there. Yeah. So the first column is fine now. And look at this one here. Yeah. You can sort of factorize this, right? If you multiply them out, right? So you're going to get 5 minus 10, right? And then plus 2 to the k. Yeah. Oh, times 10 as well. Times 2 to the k there. But the bottom one is clearly the same. So it's already 2 to the k plus 1, because 2 to the k times 2, you can use a law of index there. What about the other one? Well, surely it should work. So we get a minus 5 there for the number term. And I mean, if you pull 5 out from both terms, you have left in this term 2 times 2 to the k, right? And then because this is minus 5, so you have a minus 1 here, yeah? And isn't that, this together is 2 to the k plus 1, right? Just keep writing that, basically. 2 to the k plus 1 minus 1, and 2 to the k plus 1 here. So that is the same as this guy, right? Yeah? So this is, yeah, from the definition of the formula, and this is what we worked on to get it. So therefore, true for n equals k plus 1. Okay, and the concluding step, since it is true for n equals k plus 1 when true for n equals k, therefore it is true for n, this one is n, yeah, n natural number, as it is true for n equals 1. So basically you just match up the k and the k plus 1 and the n equals 1 and the n equals any natural number. Yeah. This is the when true for this and true for this. So if it's true for this, it's going to also be true for any other number that you can add on by 1. So that's what we can write by mathematical induction. There you go. Okay, so that's it for part A. Okay, part B. Describe fully the single geometrical transformation P represented by matrix B. Okay, so the way to go with that is to consider the basis vectors. You look from the column here, from the top. Well, the untransformed vector would be the identity vector, the identity matrix. So if you look from here, it's going to be the matrix I. It's just the basis vector along the x-axis. Yeah, that's the I, and the j is just the, so this is 1 0 and 0 1, the I and the j, right? The I and the j there. So as you can see, the j doesn't change. You go from here to here, the j doesn't change, so there's no transformation about the j. But the I from 1 0 to minus 1 0, so that's kind of like flipping, right? It's flipping the x-axis. So this is indicating that I from there is going to be flipped to this side instead. I call that I prime. So that is reflecting in the y-axis. Yeah. So therefore, it's going to be reflection in the y-axis, so that the x values reverse, yeah, by that transformation matrix. Okay, so part C. The transformation Q is represented by matrix A to the n, the transformation P followed by transformation Q. So P followed by Q, so P would be on the right part and Q would be on the left part, is the transformation R, so R equals QP here, yeah, which is represented by matrix C. Oh, fine, okay. Matrix, okay, hang on, let's do R and then QP like this. Okay, I'm just going to do R is P followed by Q, okay? So matrix C is going to be equals to the matrix of transformation Q, yeah, which is what? Q represented by A to the n. So Q here, and then the matrix P, what's matrix P? B, yeah? I mean, they kind of use redundant letters here. So it's a letter of the transformation, and it's the matrix, the letter for the matrix. So basically, you have to put the matrix for transformation P on the right because it happens first. So that's why I put B here. And then the matrix for transformation Q on the left because it happens later. Yeah. Okay, so that's the matrix C then. Now we are given that we determine C in terms of n. Okay, that's fine. So A to the n is just 1, 0, 5, 2 to the n minus 1. We're going to use from that, right? That's A to the n. And then this is multiplying by that. So basically, we're just reversing. Yeah, we're just going to multiply that out. So it's going to be, so basically minus 1 here, I guess, and 0 here. Doesn't change. Yeah. Wait, hang on. Yeah, and that should be the same. And yeah, this should also be the same. Yeah. Let me double check everything. I mean, you can try multiply that out. Should get the same there. Okay, yeah, basically just put a minus sign there, right? It's just flipping the sign of the x value, basically, if you can imagine that. Yeah, I'm happy with that, I think. Okay, that's basically it for C. Part D. Given that for a particular value of n, the transformation R maps the point with coordinate 27, 1 to the point with coordinate AA, where A is a constant. Determine the matrix that represents the transformation Q. Transformation R. Oh, transformation R is basically the matrix C. All right, so C. Okay, so basically we're going to do C, matrix C here, multiplied with the coordinate 21, 27, 1, and put it equal to AA like this. So 27, 1 is the original point. Map that to the point with coordinate AA. And the matrix C is basically just the one we got earlier, which is minus 1, 0, 5, 2 to the n minus 1, and then 2 to the n here. Yeah. Okay. So if we multiply out, right, we should get the top and the bottom component. And because they both must be equal to A, we're going to equate them already. So the row multiply column here, I get minus 27 plus 5 to the n minus 1 equals the other one, yeah, which is 0 times 27 plus 2 to the n times 1, so that's just 2 to the n there, okay? Simplifying all this, we get minus 27 plus 5 times 2 to the n minus 5 equals 2 to the n. Collecting terms, we have 4 times 2 to the n equals, moving 32 to the other side. So that's basically 2 to the n plus 2, because 4 is 2 to the 2, and I use a law of indices to merge them. I get that, well, basically n plus 2 must be 5, right? Because it's 2 to the n plus 2 equals 2 to the 5. So n equals 3, no? Yeah? We found it. So determine the matrix that represent transformation Q. Now Q is a to the n, so n is 3. That means Q, which was the matrix a to the n, right? Which is a to the 3 instead. We're going to use the formula here, a to the n, there, which will be 1, 0, 5. So we plug n equals 3 in there, we get 8. 8 minus 1 is 7. 7 times 5 is 35, yeah? And 2 to the 3 is 8 as well. So that's going to be the answer there then. I'm just checking. Yep, that should be fine. So that's matrix, yeah, Q, a to the 3. Yeah. I put it right. Yeah, okay. Next, okay, we're at 30. Number 4. Part I, Z1 is that, Z2 is that, A, B, C are real constants, given that B greater than D. Okay, Z1 plus Z2 is real. Okay, so they give you a bunch of information that show that A equals 2 and determine the value of B, C, and D, right? Okay, we're just going to go one by one. Z1 plus Z2 is real, so that means if we add them up, right, it's going to be A plus C plus the imaginary part is B plus DI, like that. Because it's real, so that means the B plus D is 0. Or we can say B equals minus D, right? That's the first thing, first information. The modulus of Z1 is root 13. So we have square root of A squared plus B squared equals root 13. So basically just going to do A squared plus B squared equals 13 then. The modulus of Z2 is 5. So that's basically, again, similarly, C squared plus D squared. I'm just going to do 25 here already then. Okay. And then the real part of Z1 minus Z2. Okay, let's do Z1 minus Z2 first. Wait, real part? Yeah, we can do the real part minus the real part, right? So that's going to be Z2 minus Z1, sorry. Z2 is C, Z1 is A, equals 2. So we get a bunch of information here, and we want to solve all of the simultaneous equations there. So we are showing that A equals 2. Okay. Let me analyze what we have here. Yeah, B equals minus D. Right. Okay. Let me just think about it. Okay, I think I see it. So this one can be translated to, yeah, I see a connection between C and D. That's the way I would go with it. So this is A squared plus D squared. If you plug this into B, you're going to also get A squared plus D squared equals 13. And if I plug C minus A, substitute into the C here, I'm going to get that in terms of A too. So that will be, so C is A plus 2, right? So this is A plus 2 squared plus D squared equals 25. That's going to give me A and D as well. Yeah, that should be useful. So if we expand this, we get A squared plus 4A plus 4 plus D squared plus 25. You see that? And because we already have this, yeah, so this is basically A squared plus D squared. I'm just going to write in the column manner like this so that you can see what I'm doing here. Equals 13. So if we subtract them, do you see? The A squared and the D squared will cancel. So we get 4A plus 4 equals 12. That means A equals 2 as required. Okay, and then we have to determine the other ones. So we already show that. And then from A equals 2, we know that D would be square root of 13 minus the A squared. So that would be square root of 9. So that would be 3. Yeah. And then from that, we also know B, right? So B equals square root of 13, also minus, hang on, b is 13, yeah, minus 4. So, well, b greater than d. So b must be positive and d must be negative then, because b must be greater than d. They can't be equal. So if one has to be greater, then b will be positive and d will be negative, because when you square root both sides, you get plus or minus here, don't forget. Okay. And then what else do we have? B, C, and D. Oh, C then. C is a plus 2, so that's just 4, right? Because a is 2. Yeah? Okay, so I think I got everything there. B greater than D. Yep, that's fine. Part II. A, on the same Argand diagram, sketch the locus of point Z which satisfy that. So this is separate now. Okay, so you need to know that Z, the modulus of Z minus something equals some number. That is basically a circle. Yeah, so Z minus Z something equals some value here, which I'll put as a radius already. So it's a circle at point Z1. Note that this is a minus sign. So 12 there would be converted to the center of 12, 0, which is this point. And then the radius is 7. So radius 7, so this would be at 5, yeah? And then you have a circle here basically. Okay, I'm just going to draw a circle like that. That's not a good approximation there. Okay, let's move it up a little bit. That's it, right? Let's extend that on the same Argand diagram as well, right? So this is real Z, this is imaginary of Z. Okay, that's locus of point Z on the same Argand diagram. Okay, this is Z. And then I'm just going to do real and imaginary here because we mix between W and Z. Alright, and then we have W minus 5i equals 4. So that's basically another circle, which is now at center 0, 5, because it's the complex number in the modulus there is 5i. So that's 0, 5. Just going to put it here maybe because I already have 5 to be there. Well, you know what? Let me just move this a little further so that the points make sense there to make it a little more realistic. Yeah. The radius is 4, so it's not going to be that large. Let's make it around here because I noticed that it shouldn't cut the x-intercept because this distance should be 4, so this should be 1. And up there it should be 5 plus 4, so that is 9, yeah? Okay, so this is imaginary part. Showing coordinates of any points in intersection with the axis, yeah? Okay, that's 12, so it's radius 7 here, so we should have also 19 here. I'm just going to make this 12 alone. Be consistent with the form there, and maybe move this down a little bit. Okay, so this is W, this is Z, and then what do we have? Yeah, that's all it is, right? Do they cut each other? I'm not sure actually. Well, they might. Hang on, let me just prove something. So if they do touch each other, then their radius must add up to be longer than, hang on. So if they cut, right, this must be a minimum of 13. So the radius of the radii add up to 11. And 13 is longer. So no, they don't intersect actually. And just making sure. Okay. Now on the part B, right? Yeah. 4 and Z. Yeah. Determine the range of possible values of Z minus Y. Modulus of Z minus W, sorry. So Z is the point on the circle. W is another point on this circle. We want to find the range of possible value. So basically it's just finding the distance between 2 points on these circles. So let's say if I have 1 point here and 1 point here, what's the distance? Because that's the modulus there. Alright? Okay. So the range, we want the maximum case and the minimum case. Yeah? So the maximum case is when you have them as further away as possible. So it's going to be on one side, on this one here, and the other side here where they align in a straight line like this. That will be the case where you can connect between the distance, between the centers, and then go on towards the extreme on the large circle here and the other extreme on the small circle, and that will be the largest possible distance, right? So I'm just going to draw a line linking the two centers. I mean, this used to be in, 2024, I guess, in the PO paper, where they asked for the maximum radius or K value. I don't remember. You can go check the PO paper 2, 2024, I guess. They have this kind of question, circle. Anyway, so we're going to find this red distance first. So the maximum that they can be is basically just this line plus both radii, right? So maximum of says minus w there would just be, because the Pythagoras here is 13. So I'm just going to write square root of 5 squared plus 12 squared is just 13. Yeah, this distance is 13. We don't need to find that. It's just 5 and 12 here, and this is 13. Just a Pythagoras, so it's 13 plus the radii of both, so 7 and 4. So that's the maximum possible, 24. All right. And the minimum, right, is just this guy. Wait, hang on. Oh, the minimum is just this, right? Okay. So minimum, I just got a little surprised there because I thought I got something wrong. So the minimum, let's say, is the yellow distance there. How do we find that? Well, this whole line, this part, is 13. And the radii is just 4 and 7. So to find the yellow distance, we do 13 minus 4 minus 7. That's 2. Make sense? Make sure you understand that. So the range of possible value of that would just be logically, not algebraically, just use logic with the visualization here, is in the range of, they can be equal. So it's just 24 and 2, right? I think that's it. Yep. Just find the maximum and minimum, and then that's it. They didn't ask for set notation, so. Okay. Number 5, 3 planes are defined by the following. All right. Where P and Q are constants, given that the planes form a sheaf. All right. Determine I, the value of P. So a sheaf is like all the planes intersect, giving a line. So it's going to look like this, and then like this. I'm so bad at writing plane here, but basically all the 3 plane will intersect, and there is a line here. There is a line of intersection. There is another case where it's not giving you a sheaf, but there is a solution. It's consistent, so that's giving you a point. That is not a sheaf. Okay, this is a sheaf, so it's consistent, and there are many infinite solutions. There are infinite solutions for the 3 planes. That means they form a linear combination. That's the key. So they form a linear combination. So if I do the 3 planes in gamma 1, gamma 2, gamma 3, so I'm going to write lambda times gamma 1, this is gamma, plus mu times gamma. So gamma is basically a vector equation, the Cartesian equation of the plane, and I'll show you, equals gamma 3. So we put lambda and the whole vector equation, 2x minus y plus z minus 3. So I move everything to the left hand side first, plus mu, and then gamma 2 just x plus py minus 3z minus q. Yeah, that's a minus q there. Okay. And then equals, right? Gamma 3, 3x plus y minus 2z minus 4. That's it. A linear combination. Yeah, it's like we are putting it into a linear kind of system here. And then we're going to solve these by just equating each component. So the x component, right? We have 2 lambda from the first part, mu from the second part, and 3 from the other part. See that? From the left, the right hand side. That's the first equation. The y component, we get minus lambda from the first bracket, and then plus p mu from the second bracket. Yeah. and then the right hand side gives you 1. Yeah. For the z, we have lambda from the first brackets plus minus 3, so I'm just going to write minus 3, was that mu from the second one, and equals minus 2 here from the right hand side. And then a constant, yeah, would be, I'm just do, this is a hyphen, yeah, not a minus. Minus 3 lambda from the first brackets and minus q mu from the second brackets and minus 4 here. Basically, you need to solve these 4 equations. All right. It's probably not too obvious to do, but I mean, you can try that. Okay. Let me just try. Yeah, look, you can solve the first and the third here first. You would get mu and lambda, and that will help you solve p and q later, right? So I'm just going to do 1, 2, 3, 4. So if I do, if I do the second one times 2 first, sorry, the third one times 2, yeah, and then that will give me, it's like I'm going to put 2 lambda plus mu equals 3, and 2 lambda minus 6 mu equals minus 4 by just multiplying 2 to the whole equation, right? I get this. And then I'm going to subtract them. So I get the lambda cancel, so I get 7 mu here equals 7, so that mu equals 1. If mu equals 1 from the first equation, maybe I get lambda equals 1 as well. Just solving that, right? If we get mu and lambda to be 1 and 1, then how about we plug in the second equation? Yeah, so it would be minus 1 plus p equals 1, so that means p equals 2, right? And we also sub in the fourth equation here to get q. That means minus 3, because lambda is 1, minus q, because mu is also 1, equals minus 4. So that means q is 1. Yeah, just solving everything there. We already got both of them. So this is part I, this is II for the answer, yeah? P and Q. That's done. That's a sheaf. All right, just going to go ahead and do number 6. Not too bad. Number 6, the quartic equation, blah, blah, blah. They have A in both terms, né? Where A is a real constant, has roots, blah, blah, blah. Nice. A, determine the value of these. Okay, so with the roots of polynomial equations like this, you got to know the tricks how to remember the thing. It's not like you shouldn't remember them as R, because it's tricky. You should have a trick to remember them. Let me show you. I mean, relevant to this question only, yeah? So if we sort of do something with that, simply we can factorize that out, right? We can factorize 3 out, so I get this first. Because we want to determine this, yeah? Delta there, okay. That's gamma and delta, alpha, beta, gamma, delta, right? A, B, C, D, basically. Okay, now, if we want to find all this, right? I mean, if you do the lowest common multiple, then you are basically gonna multiply each of them by the things that they don't have. So like the first term, you're gonna multiply by B, gamma, delta together. So I'm gonna have beta, gamma, delta here, yeah? And they're gonna all have the same denominator because we're basically merging the fraction here. So this is alpha, beta, gamma, delta, yeah? And the first term is just beta, gamma, delta. The second term is just alpha, gamma, delta. It's just the things they don't have for each one. Alpha, beta, delta, and alpha, beta, gamma, right? Basically. Okay. Now, I might have a puzzle. Just, oh no, I don't. Okay, sorry. And you see, this is the sum of products of 3 roots. Now let's go from the fundamental here, because if you go from quadratic, right, when you have ax squared plus bx plus c equals 0, the sum of the roots, which are just alpha and beta, is minus b over a. Yeah, but if it's quadratic, sorry, if it's cubic, yeah, like this, then of course the sum of three roots now is going to be minus b over a as well. Basically, sum of the roots are just always minus b over a for all the polynomials. Easy. But for cubic, we can also do something else. It's the sum of two roots multiplied. So alpha beta, beta gamma, and alpha gamma, basically. Yeah? But this is one root added up. This is two roots multiplied added up. So you're going to go by another term, and that will be minus. So here you have a minus first. You're going to alternate. So this is a minus sign. This is a plus sign. So it's going to be c over a. And now what about the sum of three roots? Well, the only way to product three roots and get, there is only one unique combination of three roots multiplied. That is why I can't have any more cases, because cubic roots, there are just three. So you go another term, but you're going to alternate to minus now. So it's going to be minus d over a. I'm just saying that the quartic equation, right? Now we're going to take the actual form of this question using 2x to the 4 plus ax to the 3 minus ax to the 2 minus 5x plus 6 equals 0. Again, you're going to have the sum of all the roots, alpha plus beta plus gamma plus delta, being again minus a over 2, which is minus the second term divided by the first term. Still the same. But you're going to now alternate. So if this is a minus, you're going to go plus, you're going to go minus, you're going to go plus. The second one is the same. So it's alpha beta, beta gamma, gamma delta. It's like all the combination of two roots multiplied. But we're not interested in that, because what we have here are three roots multiplied. So the three roots multiplied, there are just four combination there, right? If I'm not mistaken. So how can you get, if you have four roots, how can you get three combination? So it's C3, 4 C3, so that's just four cases. You can do binomial coefficient, that is combinatorics. How can you get three of them combined from four of them? Yeah, so there are just four cases, so we're not out by anything. That means all those, right? All those product of three roots, the sum of them, I mean, I'm just writing now, again, will be just, I mean, if you go to the, this is minus a over 2. If you do this one over this one, it's going to be the sum of two roots multiplied. But you want three roots multiplied, so you're going to go this one over this one. But is it plus or minus? So is a minus here, is a plus here, so is a minus here. So that means I need to do minus minus 5, which is 5 divided by 2. So that's basically 5 over 2. That's just the simple way to go with this. I didn't have to remember that. So that means, oh, what about the product? Well, the product is the same, right? The same concept there. It's just the last term. Okay, what was it again? Minus plus minus plus. So it's a plus 6 divided by 2, which is 3. So that means, let me put this to the left-hand side. So left-hand side equals 3 times the sum of the three roots multiplied, which is 5 over 2, divided by the multiplication of all the roots, which is, wait, hang on. Minus plus minus plus, yeah, 3. So that's just 5 over 2. Basically it. Yeah. Just, you have to analyze the pattern there. Detect the pattern so it makes memory work easier. Given that that equals minus 3 over 4, determine the possible values of A. Right. Okay. This might be more troubling because I don't remember the... Now I don't have any pattern. Let me just check through the formula sheet here if I have anything. I don't think I will have anything in the roots of polynomials here. Yeah, you probably have to remember all that. But let me just check anyway. Yeah, I don't have anything. Nope. Statistical table. Nope. Nope, nope, nope. Okay, that's fine. Let me think about it. for the cubic equation, right? For the cubic equation, yeah? Let me just... So the cubic equation, when you have this squared, it would be alpha squared plus beta squared plus gamma squared, and then plus 2, and then the sum of the two roots multiplied, yeah, like that, which we know the sum of two roots, so that we can find that. So if I have alpha beta gamma squared and delta squared like that, let me just do the binomial coefficient first, right? This is like square like this. Okay. Yeah, I probably need to expand this, right? So let me do that manually because I don't remember. So this will be that squared. So I'm splitting this into two parts like that, and do a quadratic expansion first. So I get this squared plus 2 times this plus the last one squared, which is a gamma and delta, like that. And then we can expand them out. So alpha squared plus beta squared, yeah, plus 2 alpha beta, yeah. And then from this one, right, I'm just going to have gamma squared plus delta squared plus 2 gamma delta. And then what about this guy here? Plus, ooh, they have a 2 there. Hang on. Yeah, let's hope that that's going to be right. Okay, let's go with that. So 2, oh, they're all different. Okay, so there's 2 gamma alpha plus 2 beta gamma plus 2 beta delta plus 2, is that all? Alpha gamma, alpha delta. Greek letters are a bit confusing sometimes. Okay, yeah, you see, we have 1, 2, 3, 4, 5 combinations and 6. Okay, so this is basically, we already have this. These yellow highlighted terms added up to minus 3 over 4 as given, right? And then we just factorize the 2 out. Wait, hang on, 2 out. And then we have what? Alpha beta plus gamma delta plus, you know, I'm going to do alpha beta plus beta gamma plus gamma delta plus alpha gamma plus alpha delta. Is that all? Another term plus beta delta, right? Yeah. Okay. Now, these are just sum of two roots multiplied, which again, the same concept, we can find that, right? And what is this again? The left-hand side was just basically the sum of all roots, right? I took it from the sum of all roots, which will be minus the second term, which is minus a over 2, the first term. That would be the sum of all roots. And squared, don't forget. Okay? And then this will be, so the sum of two roots in the brackets here, right? In the brackets here will be, so what do we have? The sum of two roots. So this is the sum of one root. The sum of two roots is here. So if this is a minus, this should be a plus, right? Wait, hang on. That's a quadratic. Hang on, I got tricked by that. Let me just delete this out, right? And then, yeah, okay, let me bring the Quartic equation again. Okay, here. Right. So, minus plus minus plus. So the sum of one roots is this. The sum of two roots would be minus a, because this is a plus, so we don't change the sign. So minus a over 2. Yeah, basically. So we just have a squared here first. Just expand that. Over 4 equals minus 3 over 2 plus 2 times the sum of two roots multiplied, which will be minus a over 2. Well, same thing, yeah? Okay, there you go. So if we multiply out by 4, we get a squared equals minus 4 plus, minus actually 4a. Is that right? 2 cancel 2, and then I multiply out by 4. Yep. So a squared plus 4a minus 3 equals 0. So a minus 3 and a... hang on. Oh, stupid mistake. So a plus 1 and a plus 3. Finally, possible values of a, yeah, we get a to be minus 1 and minus 3. I think that should be fine. Phew. Number 6 is done. Number 7. The curve C shown in figure 1 has polar equation that, where A is a constant, tangents to C at points A and B are perpendicular to the initial line. The tangent at C, the tangents to the curve C at points A and B. Okay, so it's basically telling you that it's the vertical lines, tangent to A and B. Okay, use calculus to determine, okay, basically, so basically you can find the gradient. So basically we're gonna equate dx by dy equals 0, right? Because if it's a horizontal line, is dy by dx 0. Now this is dx by dy. But dx by dy is basically, you can do that by using dx by d theta divided by dy by d theta. Now what is x? X in polar form is just r cos theta, and y is just r sin theta, right? I mean, I don't remember the formula, so I need to do this. So dx by d theta is just minus r sin theta, right? And dy by d theta is just r cos theta. Okay, yeah? So if that has to be 0, if this has to be 0, right? We can multiply that out. So that means dx by d theta alone has to be 0. And that is just minus r sine theta being 0. But minus r is just minus a 1 plus sine theta. I just took the equation, the polar form equation there, and multiply with the sine theta here. And you equate that to 0. Okay? And then we're going to solve this equation. So the answer is surely one of them is sine theta is 0, or sine theta is negative 1. A doesn't mean much there. Yeah? So yeah, 0 here, so theta can be 0, right, if we solve that. And can it be pi? Yeah, it can be pi too. All right. Yeah, pi to minus pi. What about minus 1 here? Well, the case where sine theta is minus 1 is minus pi over 2. Or 3 pi over 2, but it can't exceed pi, so it's just going to be minus pi over 2. So theta is minus pi over 2. You just need to know something a bit about the quadrants and the angles there to make it faster, basically, without using a calculator. So if we want to determine point A and B, we need x and y. Because we don't know A yet, or should we know A? Is it in terms of A? We don't know A, right? A can be anything. Yeah, basically A can be anything. Okay, so okay. So x is just r cos theta, which will be okay, let me find r first. So r equals, okay, let me just split into cases. When theta equals 0, r equals, if we plug theta 0 into the polar equation, we're going to get a, right, if you can follow me there. And if theta equals pi, we plug pi into the polar equation. So sine pi is 0 also, so this is going to give you also a. If we plug theta of minus pi over 2 in, we get what? Sine of minus pi over 2 is 1, right? No, minus 1. So that's going to be 0. Okay, so that means x equals r cos theta, right? So r cos theta would be r is a cos theta, cos 0 is 1, so that's r, right, which is a, and y would be r sine theta, which is a sine 0, which is 0. Okay, so basically I'm just solving for x and y from all the cases. X equals r cos theta, so a cos pi, this is minus a, and y is a sine pi, this is 0. Yeah, and what about this one? X is a, not a now, 0, so that's going to be 0, and this should also be 0, right? A, because r is 0. Wait, is r 0? Oh no, hang on. Oh yeah, r is 0, so yeah, r is 0, so 0 for both cases. So let me think. Then a must be the one on the left, which is negative x, so which is minus a, and y 0 here. Ooh, that doesn't look like 0 there. Sine pi is 0. I mean, O is the origin, right? Is it? Does it say O is the origin? It doesn't say, does it? I mean, because if it's the origin, then it shouldn't be 0 there. Because 0 should be like down, not there. It doesn't say. Okay. B is then on the right part. Oh, but the initial line should be on the x-axis. Okay. Well, I'm just going to write that first. Is there anything wrong here? Okay, let me look at my sine theta and everything again here. Yeah. So if we put 0, a is r, and r should be a, y should be 0. Do I get tricked by this curve here? I mean, let's carry on first. Yeah, I'm not sure about this. Let me check that later. But let me do part B first. The curve C models the perimeter of the surface of a swimming pool, given that according to the model, the distance across the pool from A to B is 10. Okay? Yeah, probably not right now, because if A and B are on the x-axis here, then 2A must be equal to 10, so A should be 5, but it's not 5. It's something else, so something wrong with my calculation here. dx by dy is 0. dx by d theta is 0. dx by d theta is, oh, wait. I haven't differentiated this properly. Okay, this should be a chain rule. Yeah, okay, but x is r, which is a1 plus sine theta times cos theta. I should have done that. So, okay, let's put that into equation properly first. So it's going to be a cos theta here plus a sine theta cos theta, right? So dx by d theta, we should differentiate that. So this is minus a sine theta. Okay, a product rule there. Well, yeah, okay, we can do that. All right, so plus a u dv, so u dv plus v du, so cos squared. Okay, so what's that? A minus sine theta, and that's going to be minus sine squared plus cos squared. Is that right? Yeah. Sorry about this. This whole thing is collapsing. Okay, so and then we're going to put that equal to 0, right? Let's look at that equation of how to solve it. Oh yeah, we're just going to put that equal to 0, right? But, you know, cos squared is 1 minus sine squared, yeah. Okay, so we get minus 2 sine squared x, theta, sorry, minus sine theta plus 1 equals 0, okay? And then, so it's 2 sine theta, sine squared theta plus sine theta minus 1 equals 0. So if I, maybe hopefully I can factorize that. So it's just 1 and 1. So it's a plus here and a minus here maybe. And this whole thing collapsing. So yeah, is that right? Yep. So sine theta is minus 1 or sine theta is 1 over 2. Again, the minus 1 is going to give me minus pi over 2. I remember that. But this one, 1 over 2, well, I know that arcsine 1 over 2 is pi over 6. So pi over 6 is in the range. Can I get minus pi over 6? Yes, absolutely. Yep. So 2 answers there. Okay, and the hard work of finding A and B again. So, okay, so, if theta is minus pi over 2, I shouldn't have deleted completely there, right? X would be r cos theta. Well, x is here, right? Yeah. So it's going to be A times 1 plus sine theta. Sine theta is minus 1. So that's going to all be 0. So this is 0. And what about y? Y is just, we put a sine theta instead there, instead of a cos here. So this is a sine. Again, but it's still sine 1 plus sine theta is 0 anyway. So yeah, I is 0. So this is also 0. So that's the origin. If theta equals pi over 6, I think these two are going to give us the thing. X will be, what is r? Let me find r first, right? Because we can use that. So r will be a times 1. So pi over 6, sine pi over 6 is 1 over 2. So 3 over 2 there. So it's 3 over 2a. That means x will be 3 over 2a times cos theta, right? Cos theta is cos pi over 6, so that's root 3 over 2. So it's 3 over 2 times root 3 over 2, basically. Yeah, right? Yep. Okay, so it's just 3 root 3 over 4. And y will be r. Wait, I forgot an a here. There should be an a there. Yeah. And r is just, y is r sine theta, so it's just multiplying sine pi over 2, so just 1 over 2. So basically just 3 over 4a instead. Yeah. And then the other one should be the opposite, right? If theta is minus pi over 6, r will be, is it the same? That will be minus 1 over 2. Is 1 over 2a instead, so a is 1 over 2. Then x will be r, let me put an a here, r cos theta, so cos minus pi over 6, wait, no, yeah, so, yeah, r cos theta, cos minus pi over 6, that's going to be a positive value, so that's root 3 over 2, root 3 over 2 times r, yep, that's root 3 over 4a, and y is, wait, one of them should be a negative, no? Okay, I'm troubled now. Y is r sine theta, r a over 2 times sine theta. Sine of that is minus 1 over 2. Oh, this one. Wait, what? Doesn't make sense. Minus a over 4. Doesn't look like this. Doesn't look like it's gonna be that. I should have x plus and minus. Not like this. This is not what I expect. R is 3 over 2a. So x is, oh wait, x is r cos theta. Cos this, oh that's right. Cos of this is root 3 over 2. Yeah. So that should be right. Sine of this is, so it looks like B should be this guy, and this one, R is sine of this is basically minus 1, it's 1 over 2, and then, wait, something is missing here. Minus 1 over 2, 1, cancel out. I'm just thinking, guys. Sorry. My time is running out too again. This is not good, not good, not good. I hope I didn't solve anything incorrectly there. Wait, how? Oh, I see. This is not minus pi over 6. It should be 5 pi over 6. Oh, how can I get that? All right. So the pi over 6 is correct, except the minus here. Okay. Yeah, the roots didn't make sense at first, so this should be wrong. Okay, let's solve for the r again. Sine of minus pi over 6 is again pi over 2, right? So pi over 2 there, so it's the same radius here. Good. Thank God. Okay, so root 3 over 2a times cos theta. Cos of that is going to give me a negative number now. So cos of pi over 6 is root 3 over 2 is negative root 3 over 2. Yep. So it's negative 3 root 3 over 4a. And y should be the same. I bet it should be now. Okay, so a is just negative 3 root 3 over 4a. And y is 3 over 4a. And b is on the right. So 3 root 3 over 4a, comma 3 over 4a. Phew. Okay, part B. Show that a is that. All right, so they give you that distance from a to b because they have the same y. So it's 2 times 3 root 3 over 4a equals 10. Yeah? So cancel that. So you get a equals 20 over 3 root 3. Yep, if you multiply root 3 over root 3, you're going to get 20 root 3 over 9, which is as required. Yeah. Now C, use algebraic integration to determine the surface of the swimming pool. Surface, the whole thing, right? Yeah, so I think the whole thing. So we go from initial line, sweep to the other side. Or we go from here to here. Okay, let's do half, right? So I'm just going to do half. That's the initial line. That's the origin. Let's do this half, yeah? So this half, right? Because the minus pi to pi. So b here, pi, minus pi. Is that pi here? Okay. Okay. How do we do this? Should we integrate the whole domain? No, they're going to cancel out, I think. We should split in half and... Aha! So, because I know that at the origin, at x equals 0, y equals 0, we can find the r and theta. Yeah? R and theta would be... We got that before, remember? We got the origin before here. So... r is 0, right? R is 0 there. If you plug that back to the equation there, r would be 0. But theta is minus pi over 2. Or plus pi over 2. It could be, no, it couldn't be plus pi over 2. Minus, yeah, if it was pi over 2, then, yeah, it would be something else. So hang on, let me think about that. Yeah, it should be minus because the angle is here. So that's the initial line, that's the angle, minus pi over 2 there. Okay, so we're going to integrate from minus pi over 2 up to pi over 2. This is pi over 2, right? From the initial line. So it's just the integral minus pi over 2 to pi over 2, 1 over 2, r squared d theta. That's the formula, right? So 1 over 2 r squared is basically a squared. Just going to keep a squared first, and this will be, you know, I'm just going to expand the whole thing. So 1 plus 2 sine theta there plus sine squared. Yeah, I'm expanding the whole thing already, and this is integral. Let me just take 1 over a out like that, and integral here. Yeah, because r squared is a squared, and we have a half there, and this is the theta. All right, just set up the integral first. Then we can deal with the substitution later, but you know, if you substitute, if you integrate each term, you get theta here plus. Integrate sine, we get a minus cos, so minus 2 cos theta there. Well, integrate sine squared, right? So sine squared is basically, if you use the double angle from pure math, yeah, the old guy there. So sine squared theta is just 1 minus cos 2 theta divided by 2 like that. Yeah. Okay, so that's basically plus theta over 2, integrating a half there, and integrating cos to theta, I get sine to theta. Integrate cos, we get sine, right? And using reverse chain rule, we get over 4 here because you have to multiply 2 there as well. And that's it for the sine squared. And then we plug the bounds in, right? Okay, so just work on this and we should get the surface area. I have 10 minutes left. Okay, so 1 over 2a is 400 over 81 and times 3 there for the a squared. And then this lot, okay, let's see. Is there any simplification? No, probably not. So, okay, I'm just going to move this here. So, okay, this can simplify to 3 pi over 2. So 3 over 2 theta, I mean pi over 2, minus 2 cos pi over 2. Cos pi over 2 is 0. All right. And then sine 2 theta, which is sine pi there, if you substitute in, you're going to get 0 as well. So that's 0. Okay, actually simple. And then 3 over 2 here, substituting minus pi over 2 in, you get that. And then you would have again cos minus pi over 2, that's going to make 0 as well. Yeah, that's going to also be 0. And that's it. So this is the thing. This is it. So these are going to add up. So you would get in the... Okay, yeah, that's actually simplified. All right. So we would have 1/2 times 400 times 3 divided by 81, right? Half 400, 381. Is that 3 actually? Wait, was it 3 here? Yeah, it is 3. Can't be sure about your handwriting, right? Wait, where's my 81? There you go. Okay. And then in the brackets, right, I have 2 of the 3 over 2 pi over 2. So if I multiply that by 2, I get 3 pi over 2. So multiply 3 pi over 2. So can we get an exact? It doesn't have to be exact. Okay, I'm just going to do 34.9 blah 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 and round that to 35, and the units will be meters squared. All right, so I'm just going to go with that, guys, because I don't have much time left. Number 8. Given that blah blah blah, show that blah blah blah. The fourth order constant to be determined. We're just going to keep differentiating. Okay, so y dy by dx first. So differentiating cos, we get a minus sine x, and then we do product rule here, sinh x, and then plus sinh x, no, cos x times differentiating sinh, we just get a cos, because that's easy. There's no minus sign there to remember. D squared y by dx squared. This will be, I guess actually, maybe we want to try use the Leibniz rule, but that's further math 2 or something, not core pure. But anyway, yeah, just do product rule again. Gonna get pretty tedious now. That's horrible. Okay, minus sine differentiating sinh, I get cos, yeah, and plus minus cos here, and a sinh. That's just the first term, guys. And then differentiating the first term, I get minus sine x. Second term kept the same, and then plus differentiating the second term for that one, I get a sinh x. Okay, can we simplify this actually? Okay, yes, we can. So minus 2 sine x cos x, and these cancel. Right, good. All right, at least. And then we have d cubed y by dx cubed. Just going to differentiate that. Hang on, but is it similar to anything? No, it's fine. So minus 2 times cos x plus sine x sinh x, like that. Isn't this, wait, let me look at the formula sheet. I think it's a double angle, right, for hyperbolic form. Yeah, it's some kind of double angle, I think. It's some kind of double angle. Where's the formula sheet for further math? I'm just looking at the formula sheet, guys. Hyperbolic. Yep, okay. No, it's not actually. Wait, hang on. No, sorry. This is not, okay, it's a cos and a cosh, so it's a mix. I should, yeah, okay. Let's just keep it like that. All right, let's differentiate it again, yeah. So the fourth order now should be the last one. Minus 2, I'm just going to differentiate inside. So differentiating cos, I get minus sine. Keep that the same, I get cosh. Ooh, 4 terms, yeah. Differentiating the second one, I get a sinh. Now on the second one, differentiating the first, keep the second the same. Differentiating the second, keep the first the same. Okay, so what is this? Minus 2 sine x and cos x cancel. Cos x, so this will be minus 4 cos x sinh x, which is actually, yes, 4 y. Yep, we have proven that. It's just minus 4 of the y, basically. Hence, determine the first 3 non-zero term, the Maclaurin series for y giving, okay, Maclaurin series, right? Okay, I can show you the formula sheet here. Maclaurin, come on. Yeah, there we go. So, non-zero terms. Okay, so, yeah, y equals f, x equals f0, first non-zero term, plus x, f dash 0, plus blah, 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 right? So f0 would be, so f0, just plug in the y there. Cos 0 is 1, sinh 0 is 0, so that's 0. Okay, so that's not counting. And then f dash, so f dash 0 here is just, we take the first derivative, which is this guy here. If we substitute 0 in there, what do we get? The sign disappears, the cos becomes 1, so cos 0, it's 1, right? Yeah, it's 1. So you're going to get 1 out of this for the second derivative. Okay? And then double dash 0, you got to keep finding. So just going to do 3 terms here. So we have double dash being this one. So x0, that's going to disappear. All right. So the third order, sub 0 in here, yeah. We get 0 for this. We get 1 for the cosh, so it's minus 2. And do we have it? Not yet. We got to keep going. Order 4. Order 4 is just basically minus 4. Wait, is this order 4, not 2? Order 4 is just minus 4 times the y, which is 0. That doesn't work. First 3 non-zero term. Hang on. F0 is basically 0. Yeah. How do you have okay. So it's got to be the first derivative, the third derivative, and the fifth. Okay, fine. We're just going to go with the fifth derivative. I just keep adding that. So what do we have for the fifth derivative? d5y by dx5 equals just minus 4 dy by dx, right? Which is, which is minus 4 dy by dx. Okay, minus 4 dy by dx at 0 is 1. So that's just minus 4. So basically, y equals fx equals, the second, so the first derivative is x times f dash 0. So that's x. X is, wait, what? Oh yeah, x. So just x, sorry. And then the third one here, minus 2. So minus 2 times, this is the third one, right? So the third one is x to the 3 divided by 3 factorial, which is 6. And then the fifth one, which is minus 4, so minus 4 times x to the 6 divided by 6 factorial. Yeah, so that would be x minus 1 over 3x cubed. Wait, that should be x to the 5, not 6. Sorry. Yeah. The first one, the second one, the third one. Yeah, so the fifth one should be, yeah, okay. And this should be 5 factorial. So basically just 5 times 3 times 2, so that's 30. So 1 over 30, x to the 5. I think, yeah, that's it. And I'm out of time. I can't do this last one. I'm done. See how many marks I got, right? Yeah, I'm out of time. Number 9 is going to be in the correction. So I'm going to stop the timer now, guys. Okay, I have marked the paper. I lost 10 marks, guys. At least better than the paper 1, actually. Although I missed one big question, didn't have time to. Again, because I had to talk while also walking through. So that might take a bit of time. That would just be my only one excuse here, all right? But I'll explain the last one anyway, the one that I skipped. But let's go through my mistakes first. So number 1 is fine, yeah. So I'm going to review the question as well, yeah, as well as correct them if there's any mistake. So number 1 here, yeah, everything is fine. Just make sure you know the definition of modulus and argument here. This is just plain simple complex numbers equation, question. So that should be fine. Number 2, yeah, I made one mistake at the end there, but yeah, this one is basically linear algebra of vector and planes and everything. So you need to know the definition of a plane and how it works in Cartesian and vector equation, and also a vector equation of a line. Yeah, try draw some diagram and visualize, right? I would say that would be my suggestion there. And I made a slight mistake here. I was mistaken, yeah, about the angle thing. So actually the angle, we find theta here. So it was right that either acute or obtuse, yeah, there will be an acute angle anyway somewhere. But when we have a normal here making an angle theta to the line L, it should be this angle here that we need to find. So you have to do 90 minus theta to get that angle. So I would have to do 90 minus theta there. Yeah, that's what I didn't do, so I lost 1 mark there. But I got the dot product there, so there's a method mark. Just that I didn't do the last bit, which is to just subtract from 90 to get the actual answer there. All right. So that's the second question. And yeah, make sure you understand like the part A, B, C. Yeah, and part D and E are just easy. So part E here, basically, there is a common question almost in every paper in A-level, right? If you notice, in math and further maths, like they want you to think critically about what went wrong about the model. Yeah, like the realisticness of the model when compared to the real world application. But you know, the very simple hint is that whatever they assume, we will use that. Yeah, like in the model, like these bullet points, if you feel like something is wrong about that, like pick the one that is seriously wrong, like you feel like it's gonna be the most wrong about the reality. Like the path of the arrow there is actually a curve, right? Because it's a projectile, or it will be a parabolic curve. Well, arrow being a particle is kind of maybe okay. It's not as bad as the path being straight line there, because obviously it's not a straight line. Yeah. And yeah, that's it for number 2. Number 3, I don't think I made any mistake here. Yeah, I got all of them. So proof by induction. Make sure you understand all the steps. Also, make sure you know how to do the other 2 types in proof by induction, which is the series one, and also the divisibility rule, like divisibility type of question, and also this one, matrix. Yeah, so there are about 3 typical types that will come up in proof by induction in further maths. Yeah, and then part B, describe fully. Yeah, make sure you understand I like what I explained about how to get a simple way to just work out the description of the transformation of a given transformation matrix. Yeah, that's very simple there. Part C, right? Yeah, part C is just fine. So you just know that the order of transformation by two matrices multiplied like that, you know, the transformation that happens first needs to be on the right, because when you multiply it to something, let's say you want to transform matrix T to T prime, it's going to be B that would be multiplied to T first. So that's why we put it to the right, yeah. And then this one is just fine, just equate them, and we know that they both equal to A, so the first component and the second component must be equal, so that's why we got that equation and solve. Number 4, I don't think I make any mistake there. Yeah, everything is perfect. I would say make sure you understand part IIA here. Yeah, the fact that I got, yeah, and also part B. Part B is the highlight actually, yeah. So if you draw the diagram, not have to be the best diagram, it's just so that you understand what happens here. Yeah, everything should be roughly accurate, but not precisely accurate, you know what I mean? So like the scale doesn't have to be that perfect. I mean, look, my 1 here is just slightly above the x-axis, but 5 is quite further away, so of course it's not to scale here, but I put everything that I need to, which is fine. Now the point here is that you need to understand about the circle, the two circles here. The furthest distance and the closest distance between the 2 points on both circles, it is appeared before last year, yeah, in pure math, paper 2, I think. I remember that because I walked through it already. If you haven't seen that, you can go check. But yeah, it's just that when you consider the shortest and the longest distance between these 2 points, the line that connect the center would be the line that you will look at, right? So the shortest is between these two and the longest is between these two. Yeah? Okay. And then I got this inequality there. That's right. Number 5, yeah, sheaf. There are other cases where you have only one intersection. A sheaf here is when you have infinite number of solutions where the 3 planes intersect in a line. So there is a line of intersections, basically. It's a line that contains all infinite number of points of intersection, and we say that it's consistent and has infinite number of solutions. Yeah, there are cases where they don't intersect at a single point, so we call them inconsistent. Yeah, and there are other cases where, three planes are actually the same plane, so that's consistent and many solutions as well. There are cases where there are only 2 planes that are parallel and 1 plane intersecting the 2. That's also inconsistent because you won't have any solution there. So if there's any 2 planes that are not the same plane and are parallel, that's already going to give you an inconsistent solution, right? If they are inconsistent and don't give you any solution. Okay? Yeah, so that's the whole thing. Make sure you understand the linear combination method here. If it's a sheaf, yeah, it's a sheaf there. Okay, so a sheaf look like, if you look from a cross section, yeah, it's going to intersect like that. So looking the plane from the cross section, and you can draw that, like this is one plane here. I mean, I'm not good at drawing this, and this is another plane, and this might be another plane just intersecting in a line like this, yeah. You look from the, that's a bad drawing actually. But if you look from the cross section, it should look exactly like that. Yeah, cross section. Okay, so if you draw another dimension there, they're gonna intersect on this line. Yeah, there will be a line of intersection there. Okay, that's a sheaf. Okay, and then you solve simultaneous. It's just that when you get to this this step, might be a little tricky if you are like not proficient at solving simultaneous equations, more than 2 equations. So these are like 4 equations. But look at some 2 equations that will already give you some answers. Okay, there are cases where it might be more difficult than this. I mean, in other examinations, I mean. But I think in A level here, they're not going to do that bad, right? That hard, I mean, yeah. Number 6, right, is roots of polynomials. So this is beyond quadratic now. Yeah, beyond quadratics now in core pure 1 in AS, but this is also other. I don't remember because I looked at the pattern and I understand how you can work from quadratic, cubic, and quartic, and even higher order than that. It's going to be a pattern. So make sure you go back to that question because I think I explained that clearly, like how you go from quadratic and you look at the sum of roots and product of roots. So when it's cubic, you're going to have sum of roots and sum of, products of two roots. So it's alpha beta, alpha gamma, beta gamma added up. When it's quartic, you're going to have sum of roots individually, alpha plus beta plus gamma plus delta. Sum of products of two roots, alpha beta, alpha gamma, and so on. And also sum of products of three roots, alpha beta gamma, alpha beta delta, and so on. Right? I already explained everything in that, and there is a pattern for you to, get a, like it doesn't need memory, yeah, because I didn't memorize them either, and I got it right, yeah, okay, yeah. So let's try learn that. Number 7, I think it took quite long to just figure out the A and the B there, but the method here is fine, and plus I was mistaken again, guys. I didn't read the question carefully. They asked for polar coordinates. I didn't actually see those words. Yeah, silly, right? They asked for polar coordinates. I should have been done since these, but all these work were for nothing because I didn't need to give the Cartesian coordinates. They asked for polar. So it's just r and theta. Shouldn't have happened. And I lost valuable time. I didn't get to do the last one. I mean, if I didn't, spend too long figuring this out, then I would have a little time to do the last one and probably better marks there. But, okay. So I got the wrong answer here because they want polar forms. And part B, part B is right. We proved it. And then algebraic integration. Yeah, another wrong one because I told you that I would do 1/2, right? But I forgot to multiply by 2. So this should have been 70 in two significant figures. Yeah, was definitely in a rush there because this is almost the end of the paper now. And this one I got, this one I got it, I think. Yeah, almost, barely. You have to differentiate quite a lot there and just keep differentiating. I believe in, because I walked through it before, further like the paper 3A or 4A. I think 4A, there's something called Leibniz method where if you keep doing product rule here, then there is a formula similar to binomial coefficient actually, and then it's gonna give you like to the power of 4, like the fourth order here might not be that bad, but let's say if order 8, and probably not gonna be in this paper, then in actuality people do Leibniz method, okay. And this one is right. Almost got it wrong though because I was rushing so bad, and this one didn't do. So I'm gonna do this one now, and then we finish the paper. So number 9, given that y equals arc sine 3x, a determine dy by dx in terms of x, right? So this one basically you just have to move the arc sine to the other side or reverse the arc sine to be sine y equals 3x, and then we do implicit differentiation. So if I apply the operator d by dx, so differentiate sine y, I get cos y, but because we differentiate respect to x, so this must be a chain rule dy by dx here, tagging along. And differentiating the right part, we get just 3, because there's no chain rule there because it's already respectable to x. So dy by dx is going to be equal to 3 over cos y. Now cos y we need to find in terms of x. So here if sine y equals 3x, then cos y would be square root of 1 minus 9x squared, right? Just sine squared is 9x squared, and then you square root of 1 minus 9x squared there. So this will be 3 over square root of 1 minus 9x squared, right? Yeah. Okay, so that's in terms of x already. Now part B. The curve C has equation that determine dy by dx. Give your answer in simplest form. Again, this is similar, but if you notice, the arc sine 3x here is from the one we got earlier, right? Yeah. So how about I put that? So if I put like fx, yeah, as arc sine 3x, and gx will be then cos of fx. How about that? Yeah, just put as composite function here, right? So dy by dx that they want would be just d by dx of gx. So just differentiating gx, right? So because we have a composite function of fx here, so basically that is just d, that's just d of, yeah, so if it's going to be d, hang on, let me think about that. It's just dgx by df, yeah, times dfx by dx. Yeah, so the fx cancel there, the dfx cancel. So it's basically just treat this function as a separate cos something function. So when you differentiate dgx by df here, it's basically going to be just minus sign, right? Minus sign, and then it's just like chain rule here. This is basically chain rule. So minus sign, and then you have fx inside here, right? Because you are differentiating respect to fx. So that should be what you get and nothing else on the left one. And then because we already have the fx by dx, right, which is the first part, yeah, which is 3 over 1 square root 1 minus 9x squared there, right? Okay, and in simplest form, so again, sine of fx is sine of minus sine of arc sine 3x. I mean, look, you have sine of arc sine, that's going to cancel out because they are inverse functions. So if you have f of f inverse x, that's going to be x. Or if you have f inverse of fx, that's going to be x too, whatever x is. Yeah, I'm just saying that you're going to get simply the 3x in there. So this is minus 3x, right? Because you have a minus first and then the arc sine and the sine cancel. So that's basically what you're going to get there. Okay? And in simplest form, so basically we're just going to multiply out. So minus 9x divided by square root 1 over 9x squared, like that. Okay, for this part. See, I mean, if I had time, wouldn't have been hard here. Part C, hence determine x coordinate of point on C at which gradient is 4. Yeah. So C has this equation, so it's got to be from part B there. So we put dy by dx equals 4 equals minus 9x over that, right? Yeah, and then we solve for the x coordinate. That's not hard. Just, yeah. So we're going to maybe move that to this, and we have this. And then I'm just going to square both sides. How about that? Yeah. So 16, 1 minus 9x squared equals 81x squared. Right? Yeah. And then we're going to have 16 minus, that's probably 144x squared equals 81x squared. Right? Is that right? Yep. Okay. Yep. So this is 16 equals 5 to 2x squared. I think x squared will be 16 over 2 to 5. So x will be plus or minus 4 over 15 if you do the square root. But we want only one. So which one is not in the domain of this? I think the minus 4 over 15 is not, is it? Wait, hang on. 4 4 over 15 is less than 1 over 3, right? 4 over 15 is less than 1 over 3. So actually both of them are in the range. Okay. Both of them are in the range. So, hang on. But let's try put x in here. So minus 12. Yeah, that's fine. Interesting. Hang on. Let's try put this back into this. See which one doesn't work. I think the positive one might not work. Yeah. If we put no, that they should. Oh, if we put a negative one here, hang on. I see. Because when you put, okay, this one will always give you a positive anyway, right? But if you put a positive into x, your gradient will be minus 4, not 4. So we need to reject the positive one in this case. So we only get the negative one, because if we plug it in, we get a positive gradient, which is 4 there. Okay, so that's the answer there. And that was it, guys. So I hope that was all useful. Do check out the paper 1 and other further maths paper in the channel. If you haven't checked my channel, please go check my channel. There are more videos on A-level and stuff. Also other examination papers that might interest you. So please don't forget to subscribe and stay subscribed, because I'll keep making more and more videos. This is during the term break, but I still do make more videos, as you can see. And I'll see you in the next video. Thank you. Bye.